Good morning. It's not morning for me. For you, maybe. For you, maybe. Let me start some tea happening. What kind of tea? We're going to do more hot cinnamon spice black tea. Even though the sun is down, we're going to do that anyway. I'll give a couple more minutes for people to show up. Maybe when I start my tea steeping, we will begin. We get yelled at for having hazelnut coffee? No. We don't yell at people for drinking coffee around here. We just feel sad that they don't know the right drinks. That's all. What's the main purpose of changing the transactional movement? I explained this for some minutes at the beginning of the previous stream. So since we haven't started yet, you could kick over there and see the explanation. You only drink chai and water? See, that's not that bad of a policy. That's pretty good. Chai and water. Okay. Let's talk for a second about what to work on next. Previously, today, we were going through the new movement transaction system, and fixing problems, and we added a lot more assertions to try to ensure that our game state remained reasonable, and we fixed some problems that were detected that way. And now we can run all the tests on all the levels. We don't pass many of them. That's expected. In fact, we fail 144 tests. A lot of these are timed levels, and it's not surprising that we would fail those tests because the timing has to be different now. However, some of these are suspiciously not timed levels. For example, all of these, well, these ones for sure, are not timed. And so I was looking at this after the stream, and I realized that there's now a little problem, which I will illustrate for you. And in fact, let's just make this our default level that we start at. Okay, so here's the thing. If I'm here and I tap up twice, for somebody who's playing through the game and wanting to just knows what they're doing and knows how to solve the puzzles and they're in the flow, you obviously want to push the block, right? It falls into the water and then you walk over it, right? So you want this to happen. You want to go push one, push twice, and now I'm on it, and then the third time I'm across it, right? So if I tap 3 times, I should end up on the other side of the block. However, we've changed the transaction system. So in the old version of the system, if I push something that would fall, it would attach that falling motion to the same transaction as the push. The old system supposedly had transactions as well, but they weren't as robust as the ones that we're doing now. So the next player input wouldn't be processed until the thing had fallen out of its current square. But now that is not how it is. So if I tap twice here, watch what happens. See, he like stopped and didn't walk onto it because he was blocked. Like here's, whoops, let me see. We'll just slow down time a little bit. Tap, tap. See, he goes there and then he's kind of blocked and then he stays on his square. And it's because as soon as this transaction finishes, we try to run the next user input. And it's like, oh, I want to go forward. Oh, but wait, there's a block there now, right? And actually, the other thing that changed is this block used to move out of its position like immediately, because when you would start a move is when you would change which logical gameplay square that you're occupying. And now that doesn't happen for a while till it's like halfway down to the next square, probably. And so that also means there's a much more wider window for us to get blocked. So I'm trying to think about what's the best way. Animation, like turning is also messed up right now, so we're going to have to look at that later. But we're going to have to try to look at what is going on. Like, what's the best way to do this? There are 2 ways. One is when something starts falling. There are multiple ways. One is when something starts falling, we could try to attach it, well, not try, but just attach it to the player transaction, right? That seems doable, except it sort of breaks our rule that we want transactions to fire once and set their physically moved flag and then be done. But we might cause the reason we added it to that transaction before is that in the old system, the ID of that transaction was stored in a variable somewhere that told the input system, don't process any more inputs until this transaction ID is complete, right? Instead of doing that, I think now, and we can verify this, but I think we just have a Boolean on each transaction that says whether it blocks player input, right? So instead, we could say, oh, if something starts falling and it's a result of something that blocks player input, that is not a fall, then go ahead and continue to block player input, at least for that first falling transaction, so that cases like this work correctly. I'm inclined toward doing that, if that will work. The third thing we could do is have some kind of timing thing, which we may have to add eventually anyway, where maybe we don't do either of these transaction fiddlings. And instead we just say, look, if you try to move into a square and something's there but is falling out of your way or moving out of your way, then we wait until the next time at which that is empty, and then we do the move. Which sounds complicated, but we already have a version of that now for getting on lily pads and other moving things. Actually, there need to be multiple things that look at that in order to make the input the best. So that's the whole situation. But I am inclined to say right now, because it worked pretty well before, that we should just look at stalling user input processing until this fall is done, if that's straightforward. If we start doing that and it starts being really messy, we can look at the other thing. All right? Any questions about this? That are not, no questions of the form, please explain everything we're doing from the beginning, because we did that last stream. It's in the archive if you want to see it. And these will go up on YouTube later. This tea water is very hot still. Okay, so see here, we have this flag blocking player. I'm going to go double check what that does, but I think if I set that on the falling, then we're good. Okay, so this is when we set up a transaction in response to player input, and we say blocking player is true. And then, I don't know, where do we read this? Oh, in move transaction. Oh, no, down here. That's commented out. That's old stuff. So we have a no check in here to delete all. This is all the old system. So maybe here. Okay, we ask, are we waiting on player transaction? Yeah. So we just say, look, if there's any transaction that's blocking the player, then don't do another user input. So this will be relatively easy. We have this thing here called evaluate fall that we call when something falls, or when something may fall. So what I'm going to do is make a new transaction there. So when this happens is, okay, we have transactions that completed. For comp is the name of a transaction that completed. And for every one of those, each transaction is a set of moves. And for every move in that set, we do some things, right? Including evaluating whether the thing that moved should fall, right? So here we're going to say, if comp.blockingPlayer and not dot or not single dot move type or move info dot move type is, whoops, let's just put the not here. Falling, right? Then we do something. We're going to do this after. We're going to say new transaction is whatever is the result of evaluate fall. If that is set, so if something is falling, we'll get a new transaction for it, right? Then new transaction blocking player is true. Let's assert new transaction move info move type is move type dot falling, right? Because otherwise we might, like, so, oh, this is not going to be, transaction doesn't have a move info. Okay. Let's not worry about this. It's annoying to check. We'd have to loop over it. Okay, so we probably don't return this, is the thing. If we go into following, it returns a bool, which is not really enough. So we need it to be able to return something. So start falling. Okay, this is weird because I noticed we're going to have to return more info than just the transaction. We'll get there. Okay, so here, we're going to return null. Return, wait. We don't ever set transaction. Someone must create this if it, okay, here we go. So here we make a transaction if one doesn't exist. I don't think I like that, but it's okay. We can refactor this later. Okay, so maybe drown is weird. Because I don't think that is the right place for that. That used to make sense in the old system. It doesn't make sense now. Okay, so here, when we call update following entity, we return a transaction. Whoops, transaction equals new transaction. Okay. So all right, we return that transaction, right, from start falling. Not strat, start falling. Okay. So what are we going to call this one? This is a weird non-falling move. We're going to give that a default value. So we always have to return a move transaction. And then maybe, in this case of skipping, see, we're not going to, the flaw, okay. Okay. We can't return a transaction here since stones start skipping later on. But we don't need it. We only return transactions so the player can block on them. You know, instead of returning the transaction out, we could have just passed in a thing. I'm very tempted to do that. Very tempted. Do the named return values have any impact on compiler behavior, or are they just there for readability? They're just there for readability. Okay, I'm going to continue returning the transaction because maybe we will want that at some point. But if we don't, it might have just been simpler to pass a Boolean down here. You know what? Yeah, I don't like this. I don't like it. Not simple enough. It's too much goop. We will add the goop later. I'm not sure where we are now. We will add the goop later if we need it. For now, we're going to say blocking player is false, right? So, and then we just pass that to we'll do that. When we say update falling entity, did we? Yeah. Because instead of returning out transactions for weird reasons and having weird cases where we don't even really return any transaction, even though it sort of looks like we should, instead of having all that and pretending like it's a general thing, we're just going to say it's not a general thing. We're just going to yeah, okay. So, if blocking player transaction.blocking player is true. Okay, so now we need to go back to here and say blocking player is this, and then simpler for sure, probably better, unless I mess it up. Too many arguments. Wanted 2, got 3. Evaluate fall. What? Oh. Okay. Let's see if I can not hang. So there. Okay, so I can move. So let's try the fast tap. Didn't work. It didn't work. All right. Why? All right, we're going to try this. Okay, so what entity is this? This is the rock. Okay. What about blocking player? It's true. Okay. We're evaluating fall. We should no check in this particle source thing. That's fixed from stuff we did last stream. But I don't want to mess with the code right now. Okay, blocking player is still true. So I don't think we have a transaction still, right? Nope. It says blocking player is true. Okay. Do we do anything here on blocking player? Let's double check this. Well, we can go to the next do input. And just see what happens. I don't know, like I feel like, see now we have this weird thing where the key's stuck down because we haven't fixed that part of our input system. Okay, but anyway, we have, why can't I just look at the window? So it looks like the thing is over this square. So right here is where we would normally be blocked. But I suspect okay, it looks like we just returned true. So we did not enact the next buffered move. Did I just like... I don't know. We could do it the other way around. We could... See, he didn't go there. It's like we waited and he still didn't go anyway. So let's put a breakpoint where we do the blocked animation. Which is different. Blocking player in this case doesn't mean physically blocking the player. It means don't process player input. But now we're going to look for when the player is physically blocked. So do blocked animation. So we should go there. So we're going to set a breakpoint there. And let's look at what's the transaction state. Okay, so we're blocked. Same place. Where are we? Enact move, enact next buffered move. Wait, this is... Oh, this is like when we complete... Okay, so the problem is, I think we have two different... See, we call enact next buffered move from here, but we also do it from inside player transaction stuff. And the reason we do that is because, and maybe we could do this differently, but the reason is because if guys are animating, like a guy's walking forward and you have another move buffered up for him to keep walking forward, you want him to continue walking forward and not like animate to idle and then start walking again, because that'll mess up your animations, right? So I forgot that we do this twice. Enact next buffered move. Now here's the thing, this one happens after we've removed the transaction that has completed, but before we've done any that's like queued up, because that's in this evaluate fall. So we actually need to break up our phases here. Okay. Before generating moves from held keys, we need to evaluate fall for all entities because we may want to wait for that fall to complete. We are just about to iterate through all single moves of completed transactions of all entities in order to go to their idle animations or whatever, but we need to do enact next buffered move. But we need to actually, let's belay this comment. Oh, no, actually, yeah, okay. Before that, so that we know which animation to play. So we need to sandwich enact next buffered move between two loops. Psi. So this loop is all the frickin' same. And we might want to think about how to make that not so pasty later. And then, where's the evaluate fall? We just do that for every entity type. That one we probably get away with. Can skip is not. Oh, God. Wait, that's not. I messed some things up. See, this is bothering me because now I don't know what's going on here. We're going to have to play with this a little bit. Because there's all this other stuff down here that happens. But this is not just animation stuff. These are like other side effects. So maybe all the non-animation stuff should have been moved. In fact, I'm going to say that. I'm going to say... Okay, so first loop is gameplay stuff. Then we enact next buffered move. Then we do animation stuff. That makes sense. That I could live with. So we're actually going to copy this whole frickin' thing and delete part of it. And So that's animation stuff. That's animation stuff. That's animation stuff. This is gameplay. This is gameplay. Right? And then we do this evaluate fault. So now down here, we leave the animation stuff and we delete the gameplay stuff. Right? Well, who knows how bad I messed that up? Maybe there's even other things I didn't correctly do. Unreal with PHP backend. That's a quality stack, bro. Hey, I tapped it twice and I went on the thing. Watch, ready? Let's see what happens if I do the automated test of this level. It passes. It used to fail. Now it passes. We're passing all these levels now. We're going to have to do a new Benny test. Because we're just being too successful here. Boy, our turning is really messed up right now. Oh, Jesus. All right. That might be what we look at next. I don't know. First, we're going to make a release build. Are there any questions about what I've been mumbling to myself about as I say transaction this, transaction that, blah-de-blah, blah. A few months ago, I said there was a board game I liked. A logic game with clear neon-colored pieces. Do you mean Zendo? It's not exactly a board game, but that's the thing that I'm thinking of when you say that. What are the transactions in this context? They are movement transactions about what changes happen to the gameplay state of the world. Okay. We're going to Benny test it. Maybe we are spending a lot of time sending all those errors to the console. Console is pretty slow. Do I have an idea what the issue is with the turning? Not really. There is, okay, so turning is a little weird because we let the animation system control turning based on like variables that could be set or that can be read. And so I would have thought that maybe we're reporting the turning variables incorrectly to the animation system. However, when I glanced at that a few days ago, it didn't seem, I didn't see anything obviously wrong. Doesn't mean there's not something wrong there. Or it could just be that the time at which we check for turning or apply the changes or something is not working or is overridden. I don't know. We may just have to output a lot of debug info and see what's going on. Hard to say. Yes, there will be a closed beta by the end of the year. It may be a small closed beta, but there will be one. Are any more compiler demos going to happen soon? It's not clear. Like I've mostly, again, been doing like cleanup and refactorings and just improving the most difficult parts of the compiler. And those things are not that exciting to demo, but they're also very important to do. So we'll see. If you want to make your game support user modding, do you pretty much have to start development accounting for that, or can you add it in later? You could add it in later, but there are certain kinds of decisions that you might make that would make it very difficult to add in later. So it probably would help you tremendously if you knew that early in the project. Have I found out what was wrong with the for loop macros? No, but I'm cleaning up some other stuff first that should make that easier to deal with as well. There are so many things to fix that once they are fixed, we'll be so happy about. Are the features of the compiler that I deem fundamental close to completion? Most of them. There's a couple still that we need to think about. We're just cranking through the levels. Is there a smaller subset of levels that would be representative of the movement system? Representative in what way? I don't understand the question. You mean to test them faster? Maybe. I mean, if we really cared, we could just take the set of levels that failed and only retest those. That wouldn't take that long to type in, but you know, I also want to see if new stuff broke or whatever, so it's fine. This one, we're running this test in the release build, so it won't take as long, hopefully, as the one that we ran in debug build today. It should go much faster. It does look like all our timed levels are kind of failing, though. Yes, I pre-recorded those movements. They are recorded.
Telling the truth can be bad news. Telling the truth can be bad news. Telling the truth can be telling the truth can be good news. Telling the truth is a bad idea. Telling the truth is a difficult problem. Telling the truth is a scary. Telling the truth is a scary predicament. Telling the truth is a bitter herb.
See, right around there is where the timing
Telling the
failed,
truth
so
is
now
a
everything else is
dangerous tongue.
nonsense.
When you get out of that tongue, it's got bitter herb.
Black life ahead. Forget herb. I never heard of a hit that had the word herb in it.
Telling the truth is a dangerous thing.
Dangerous.
Telling the truth can be
Dangerous what? Danger.
Telling the truth can be dangerous. Telling the truth can be dangerous business.
Telling the truth can be dangerous business. Why? Why?
Why?
Why? Telling the truth can be dangerous business because if yourself, you don't know why.
Huh?
Well, I'm just giving you what the idea is.
Telling the truth can be dangerous business. If you don't know yourself, then you don't know why.
Oh, is that brilliant?
Telling the truth can be dangerous business. Honest and popular don't go hand in hand. If you admit that you can play the accordion, no one will hire you in a rock and roll band.
But we can sing.
Sing our hearts out. And if we're lucky, we'll no neighbors complain.
Ba 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 ba. Is there a video that explains in detail how to make the playback deterministic? Probably not, but it's just the same way you always do these things. All right, we are done. How bad was it? 125 failed. So we have fixed 19 levels with what we just did. Now the thing is, there may be other basic gameplay bugs. Actually, this one is a basic gameplay bug because like this gate should have opened. So I want to debug this. And then after that, we'll look at the turning problem. So what's happening here is I'm supposedly pushing this guy off to infinity. And either we're not evaluating the gates. Oh, yeah, see, we evaluated it when I moved one more square, but not before that time. What are we doing, dude? We're loading overworld stuff. All right. What level was it? Is it monster endpoint? Yeah. So let's fix this one. Let's go back to debug build. I mean, if we worked at Intel, we probably would ship this. It's only got 125 fails. What's wrong with that? Do I plan on making a game that isn't a puzzle? Yes, I do. Okay. So here I'm playing back the solution. I'm undoing to one step here. Now, okay, let's just go take a look and see if we can see what's wrong. Okay, we have this disappear after teleport flag. And we set this cause change. on the transaction, but apparently that's not being paid attention to. So since I refactored it, I don't remember. So there's post move reevaluate. That is what's supposed to notice. And move transaction does call that. If we have supports to update, who else calls this? That is literally the only place. Okay. So we're going to say, so things get added into that array when we call do physical moves. So we're going to say down here, okay, we set cause change here anyway. So we're going to say that. And that might be it. That might be all that we need to do. Let's see. We passed. Ta-da! Telling the truth is a difficult problem. Okay, so actually before the turning, okay, there's a couple things. There was this falling. We wanted to get rid of this thing because that's now being handled in a different way. There was this warning that we got where we said more than 10 transactions, and that was happening. I saved what levels that was happening here. So like mixture 3, which is a really old level. Let's run that one. What else? We regain focus when I'm having trouble concentrating on a problem. I just go do something else and come back to that problem later usually. All right, so I'm going to run this test, and we didn't get the more than 10 warning. So maybe we fixed it. I didn't save the output file from the last Benny test, so we're just going to have to run a separate Benny test later and just look for that. We're not seeing it for now, though. So, okay, let's look at turning. So I think if we just start on heroes 1-1, yeah, we can see messed up turning. Like, when does it happen? Only sometimes, like, I want to figure out how to do it 100% of the time, you know? Okay, that kind of went the wrong way. I went down, left, up. And it's down, left, up. See that? He kind of turned. Okay, if I go down left from start, he like does a lot of bad things. What if I just go down? Or left, sorry. That's fine. Just down is fine. But down left is not fine. So we have to figure out why that's happening. He's like kind of rotating the wrong way and then So let's go back again. So this is the function that returns variable evaluations to animation system. It's kind of stupid. It does string compares on the name, which is not quite as bad as string compares in C would be, because you don't have to dereference pointers to early out most of the time. You only do that if they're the same length. But yeah, so target angle is where we are facing relative to where we want to face relative to where we are facing, right? Target angle absolute. Let me just return what variables we evaluate. We're just going to, hopefully that's not going to be totally confusing. Let's just go. We're not even using LLVM backend right now. Oh yeah. So every frame, we're evaluating charmed and on exit, which is not what we want. Okay, target angle and target angle absolute, just like we thought. Okay. So okay, and then target angle absolute. See what happens. Okay, so we were going toward minus 90, which I guess was the down. And we were halfway there. And then we were trying to go to minus 180. And we got I theta of 128. That seems wrong. So from minus 50 to minus 180 seems like minus 130, not plus 130. So that's weird. Oh, but it's the absolute value, right? That's what target angle absolute means. See, if I do it in pieces like that, even, it's fine. See, when that target angle absolute shows up, oh, wait, it didn't show up there, and we still went the wrong way. Why did we turn... So rotating this way should be a positive angle, but we're saying a negative angle. So why is that happening? I mean, maybe the animation files are just messed up. You know what? Let's take a gamble. I don't think they're messed up, but we're going to update all the animations and hope that the meshes are compatible still. All right. Yeah, it's still happening. So like the animator wouldn't have left that if that was a problem. So now from this information alone, I'm not sure what to do. Let's print out the state name. So we can look at what judgments are attempting to be made here. And I'm just going to put this into target angle only, because I think that's the problem, because it's happening even when we don't query target angle absolute. So we're evaluating variable. Actually, you know what? We can just put it up here. Let's comment these out for now. So if clause variable name is target angle, then we're going to do some stuff. We're going to reprint what we had. We're going to say print okay, destination.name and state.nodes, or m.nodes, is that right? Nodes. sub state.index, or is it node index? Animation state has node index. All right. Dot name. All right. So we're going to see what happens there. Whoops. All right. We need to get our entity. That was weird. All right. Okay, so we reproduce the thing. So it's state active to walking 90 right. See, this is weird because we query the variable, we still have destination of state active. Let's just go look at the animation file. Okay, so state active. State active doesn't test target angle. Well, unless, no. Okay, I don't believe my debugging output now. Because that only tests target angle absolute. Almost everything is target angle absolute. Oh, these are not though. Oh, wait, okay. So start walks includes all this. Okay. State active to walking 90 right if target angle is less than minus 30, which it is. I guess our angles are backward. What? Okay, whatever, bro. See, here's the thing. These are supposed to be in priority order. This target angle is less than minus 120. So I don't know why we went to active to walking 90 right. I don't know why we didn't go to active to walking 180. You know what I mean? Do I often have errors due to mistyping something when using strings in a switch statement like that? Not really. I would not say that that is a very common error. If you did make that error, you would you would notice it right away. And then you never tend to change those after you've put them there. So it would be rare. to make that mistake. Okay, what is happening? This is, okay, I see something that I don't understand. I don't know if it's related to the problem or not. But I do see something. Let's see, can we figure out what line number is the rule that we are evaluating, right? Do if clauses have right, so if clause, variable name, comparison constant. Let's just print the whole thing out. And then, that's not going to be printed very neatly, but whatever. And aha! Sorry. Okay. Animation tags. These don't store the line number. Why don't we store the line number of any of these? That's a bummer. What do we have line numbers for? Well, arc. Wait, that should be. All right, see what happens with all that. Oh, look at all the spam. All right, target angle greater than. Huh. We don't print out unions very well right now. We just print the first union slot, which is not very good. We should maybe print all of them, honestly. Let's put that on the list. Print unions better. Okay. We should have a fun stream where we just make the print function better, because I have a lot of ideas about how to do that. Okay, so these are at line 600, 01, 02, 03. So those are all being evaluated in a row. I'm not sure why. Oh, these are the 90s. Okay. So the 603 fires, and then this one is later. Wait. 628, 630. Okay, hold on. Runs without foot matching 2. Wait, that's 628 though. What? Let's in order to cut this down, let's only print this on things that we're going to test for. Oh. Let's just do this for I don't know if I correctly moved everything there. Nope. Destination. Okay, see, that's not even destination, it's current node. That's not good. That's wrong. I think. At some point, that might have been the destination. Nobody even looks at it except the error message, so that's fine. That we will change. We just don't want a rat hole and fix that naming right now. Okay, so evaluate if clauses. It's called with current node. So no wonder the names weren't making sense, right? Okay. Let me just make sure to note. Oh, we did no check in that one. Good. Good. See, this is just useless. We're always printing out the same name twice, just rediscovering it in different ways. Okay. Okay, so we switched to state active to walking 90 right, which is probably correct. State running turn 180 left from right. That seems wrong. If target angle is less than minus 120. See, there's like a sign flip in here somewhere that's confusing me. I don't know if it's a newly introduced flip. See, negative angles seem to mean go right. Positive angles seem to mean go left. See, this just seems like a mistake, though. I don't know. It's confusing because sometimes, like the left and right here sometimes is which foot is forward. But sometimes it's the way you're turning, or maybe not. Like, I don't actually know. So that makes it hard to debug. Here's what I could do. All right. There's an animation graph display. Here we go. So I could slow this down, right? So he goes walking to 90 right. Whoops. And then 180 left from right. All right. I could at least see if that's the right answer by running the version of the game on my laptop that does not have any of these movement system changes, right? I mean, I could update it here on the same computer, but that would take a lot longer. And I can just see, is that the animation that is also chosen here? If it's a different thing chosen here, well, then we know why is that different. We get to look into that. If it's the same thing chosen here, then it's more like, oh, well, whatever we're doing is like not totally working. So I'm running the game, and all right, we're already on Heroes 1-1, and I'm going to go 9 and slow down. So it's, well, it totally did not. Totally did not. So here's what happens, if you could see this. I go, so it goes active to walking 90 right, active to walking 90 right. Okay, so why? And I suspect the answer may be that the angles are different when we make the query or something. Like, it sure looks like I'm like mostly done turning by the time I get into that square. Whereas here, oh, I do look mostly done turning there too. Maybe I stomp something important in the movement system. There's a complicating factor, which is, like I said before, we let the animation system kind of control turning for a while. And it might be that, so there's a time at which we transfer that information over. And like we might not be doing that. And so then, yeah, let me just start looking at that for a second. Okay, we definitely have some stuff. Turning control theta. Well, so this is exactly the same thing that's in this code on the laptop. Can I sample a bone position at a specific time in the animation graph and compare the two versions that way? I could do that. That is overkill because we don't need the bone position. There's just this overall like theta value of where the player is turning. And we already print that out here. I suspect if we print these out for the version on the laptop, which I guess I'm going to do after I heat up some more tea, I suspect we'll get a very different number here. All right, water time. For our snack, we have choco cherries, which could be good or could be disgusting. I have no idea, but we're going to find out. Because that is what we do on this stream, is we find things out. Sometimes about programs, sometimes about choco cherries. Choco cherries are pretty good, but wow, they're very sweet. If it's sweet, don't eat. Oh, I don't know about that rule. Who made that rule? Okay, I am just going to go to this print that we did. I'm just going to do this same thing on this machine and just see what it says for this case. Typing in the exact same thing. You can't see it because it's on a different laptop. Maybe Elite Subtext Lounge people can see this. Maybe not. You only know if you're a member of the Elite Club. Oh, we don't have line number. We're going to skip that. Oh no, guys, this is bad. I cannot actually build the game on this laptop. Because we're in the middle of a compiler change here. As I explained in a previous stream, one of the reasons that we are finishing this is so we can check in this change on this machine and we don't feel like we're destabilizing two things at the same time. Then we can go do a compiler thing that I realized would be necessary to most cleanly finish the compiler thing that's being done here. But until the compiler thing that's being done here is done, you can't frickin' compile the game. So I either have to check out a second compiler here or a second game here. or just not try to do this. So we're going to not try to do it. We're just going to say that line of inquiry remains open to us. Yeah, why not both? We could do both. We're going to do neither. Why not neither? I've kind of got a sugar headache now. Wow, those choco cherries are very serious. Okay, so we could differentially analyze our game situation, but we're not going to. Okay, so when we take this if statement, it's because we definitely are more than 120 degrees off. I'm going to assume that we were not more than 120 degrees off on the other system. Now this is still wrong though, which is, yeah, I think. Like, why do we, even if we did the 180 animation, why do we go like all the way around? Maybe because that one doesn't control turning. Yeah. Okay. So we could go here. Just giving a little more information. So say theta base. Theta base is like the, yeah, we can, depending on which of these is happening, which I think should be this one, but if that's not happening, then that's information. Then we could decide what more debug info to add. Now, of course, we're going to get spammed a little bit. Okay, so it says it's initted, and we're going to minus 44. And then we switch to 180. So see, I don't know why this is 0 for so long. Okay. So we're going to say player turning control theta base, player turning control. See, I wonder, because like when maybe the animation just doesn't turn for a long time, but that doesn't make sense. Like, okay, that was just a single 90, right? So we're active to walking 90 right. And we really, yeah, we're at 0 for like a long time. And only that's kind of weird. But I guess that's, if you look at the animation, he does kind of slide and then turn. Like it's like as his back foot goes. I don't know, man. That seems weird to me. But it does go all the way to 90 eventually. And then that turn is authored straight into the animation or something? Like what? Okay. If I go here, we're doing the same thing. Around this minus 41 or 44 time. We pick this animation for some reason. Let me see if it looks different how he turns at the beginning, because I can't rebuild the game, but I could like see what's up. Yeah, you know, he kind of starts turning immediately. So we might be doing something really funny. See how his foot, if you look at his back foot, it like slides parallel for a long time here, almost till the edge of the square. That is not happening here. So if you look here, when I turn, I don't know how well you could see that, but see how his foot actually turns from the beginning. So even though I can't print out the numbers, I feel in my heart like they start going up from 0 immediately. And so the question is, what in the animation system is querying something outside the animation system? It's really weird. Definitely different. You can't see the dude at all. Okay. Sorry. You're gonna have to take my word for it. Wait, was I not even holding it up in the right place? Because the camera's way over there? I don't know. If you had this playing on an 80-inch TV, you might have been able to make something out. Well, I'm sorry. Webcams have extreme fields of view. Okay, well, you can definitely see on this one how his foot moves parallel and just doesn't turn. So, okay, that is happening with this turning control theta offset. base is like what it was at the beginning. So let's go turning control theta offset. Theta relative to start. Right? Oh, that's in the data. Okay. So that's not affected by anything else. You know what I feel like? Okay, so one thing that has changed here, of course, is the time at which our character actually physically moves is different now. It used to be immediately as soon as you start the transition from one square to another, and now it's about when you walk halfway across, which is also when we mysteriously start increasing from 0 is about halfway, right? So I wonder if wow, resetting doesn't always work. If we're in the middle of a move, the reset doesn't work because of the undo problems. There we go. So one way that this happens is this controls turning gets set. And I don't remember if that gets set outside or not. There's definitely a controls turning on the animation graph. Let's look at, okay, so this code runs for every animation channel, which is like just one character animation, right? And then the player mixes those together. So here's where we reset it to 0. Here's where we initialize the base. Okay. So controls turning happens when we do switch to node. So do we like call that at a weird time? We call this when transactions complete. which should be about the same time. The time that changed was the physical move time. Or actually, we don't even, like here, we should do it immediately. Yeah, this is what I don't get. I'm going to start adding some information that dumps, like if we're controlling turning or not. So I'm just going to add that, and we'll spam that when we are controlling turning. And we'll see if that matches up to the zeros or not. So, okay, a lot of spam. So we do control turning, but our offset is 0 the whole time, which is weird. And then it goes up. Okay, so controls turning, theta relative is whatever. If this angle is actually changing but something else is breaking, then I want to know that. I mean, these won't match exactly because we interpolate between them, and I haven't actually done the work to do the interpolation, but whatever. We just want to know approximately. It really is. Wait, what? It's 0. And then it goes to minus 17. What? Okay. What's actually going on is these keyframes are pretty far apart, and we're interpolating most of the time. So one is at 0 and one is at like minus 17. And so we're getting minus 17 for a long time. But I guess there's still... I'm going to space this out a little bit to get... because I don't want these numbers to line up, because it actually makes it harder to read, coincidentally, or the coincidence makes it harder to read for some reason. So, now what? Let's do the interpolation. Oh, actually, we are just printing the interpolated value. So that is the interpolated value. So it's not really useful to print more. This is very weird. Is fraction weird? Are we replaying the animation every frame? Like one way that we could freeze at 0 is if this interpolation fraction that takes us across the time step, for some reason, is getting reset. I don't know. We're into some kind of weird thing, man. Okay. So we're in state active. We go to state active to walking 90 right. Let's make our window bigger. Of course, it can't keep me in the same scroll place when I do that. Okay, so the fraction is moving, and I'm not printing the, so this is like the fraction of each keyframe. So maybe I could also print the keyframe number. I assume that it's going up normally, but I just wanted to see that the fraction was at least moving. It's like, man, I don't know. Okay, so that's going to be in sample index. All right, so fraction so we have time divided by duration. I mean, I guess these don't. Yeah, see, I have this comment here that this is weird. This is weird. So we should clean that up. But nevertheless, we can at least print sample index down here. Sample index. Okay. See, now we have a lot fewer. Let's slow time down so we have a lot more samples. Okay, so index 0, fraction whatever, index 1, index 2, index 3 is not till frame 4 of the animation that we start interpolating, which doesn't seem right to me, but like that's just seems like what's in the data, man. Like if we were passing negative indices out here and then clamping somehow, I could see how that would stick us to 0. It's not really what's happening. I don't know what to do. Okay, so let's do a reset and let's see what this data looks like when we turn and do our wacky backwards turn. Okay, so here's where we reloaded the level. We have our zeros for a long time, which it looks like is not what the other version of the game was doing. I mean, I could back up the source and do this. No, I don't want to get into partial builds. Okay, anyway, we got up to about minus 40 whatever. Right, this is just this information is not really telling us anything anymore. But anyway, I really don't know. I mean, I kind of want to revert the compiler so I can print out, I'm going to do that. I'm not going to revert it. I'm going to copy my changes over. But at this point, I really want to confirm whether I'm barking up the wrong tree with this or not. So let's hope I don't make a mistake. I'm going to go to source and copy that and rename it as source data scope improvement in progress. Okay, we're gonna diff just to see, remind ourselves what we were doing. Actually, I think we checked in. We actually did check in the majority of what we had been doing. Honestly, this is, okay, I forgot that we checked in most of it anyway. So that even if I accidentally disaster this, it's not that bad. So we're going to revert all that. Okay, we're going to build the compiler. Hope I didn't change any module files or anything. No, not the debug compiler. Let's build the release compiler. Let's go for it, bro. Because the compiler's in C++, it takes 27 years in order to compile the program. All right. Now I'm gonna, wait, what? Why am I still having this problem? I thought let's do a clean build. Uh-oh, did I check in a build of the compiler that doesn't compile the game? I don't think so. Because I think I updated the compiler here. If I did, then I'm in trouble. Oh, it might be in modules? The change that I made? Yep, okay. Yes, okay. Okay. I forgot that this was the thing. I might have been able to not revert my stuff even. see, I had something going that was explicitly that way to exercise the compiler bug I was trying to fix. All right, so now if I try to build the game, hey, it builds. Okay, so now I have those prints. I don't have all these other print statements that we just put in, but I have the basic ones. About the do we pick the 90 or 180 and why. And here, yes. So by the time we get to the end of the thing and want to pick the new one, we're at minus 90 already. So, okay. Let's clean out this a little bit. I feel like this stuff in simulate actually is no longer really telling us that much. It's in channel here. So I'm going to put this same print over here. All right. So this is around line 270. If channel controls turning print, oh, no check-in, print channel controls turning index whatever, fraction whatever, colon, theta relative whatever, offset whatever, new line, sample index fraction theta offset 0, channel turning control theta offset. So we're going to print that out, and my suspicion is it will start climbing from 0 immediately, and then I'll be like, what the hell? Okay, so you can't see these numbers, but we start, we load the level, I start walking south, we are in controls turning, but the numbers are 0 indeed for a long time. They're the same. Except, oh! Okay, here's the thing, people. I can't believe I forgot about this factor. Okay, they are 0 for a long time. It's not that long. And then it kicks in and starts going. And the difference is, by the time we get to going to the second square, we're already at 90, right? Why? The answer is, I don't know if we draw this graphically. The answer is we're playing the animation at a different speed, because speed control was part of what we did before, and we probably dropped that when I went to the new animation system. And it's a little bit unexpected that speed control would result in you turning the wrong way sometimes, but it totally makes sense to me. So like, we're playing the animation too slow, is what's happening. And let me figure out a print to do that. So like, well, we wouldn't put this anywhere around here. So wait, we set looping, we set the initial time. Where do we do walk speed? Player speed target. Player speed. Okay. So when we call update animation on guys, we do it by player speed, and I bet this number is just lower for some reason. All right, I don't know. That's all I got right now. So we're going to be spamming this. It's probably 1. And then as we're walking, it's still 1 the whole time. I bet it's actually more than 1 or something. Maybe not. I feel like somebody would have let me know that this was a problem, but maybe not. All right, print, player speed, whatever. Maybe this isn't the speed factor that's messing us up. Maybe it's a different one. All right. It's 1 here as well. But that doesn't mean there isn't another scale factor. I feel like there's another variable. I need yet another drink because Winnie the Pooh is empty. We're getting there. We're figuring it out. We're getting there. Yeah, just do it in Rust. The borrow checker would have totally known that we're passing in the wrong speed to the animation system. Back in a sec. Kind of wondering whether it's going to be pizza time soon, actually. Okay, so the animation speed, I swear there's a variable. Maybe there's not. Default running speed. Do I use this anywhere? We did in the old system. Get run speed. Right. Okay. You know, there's a whole system that we don't have right now. There was a whole like player-based velocity driving system that isn't in there. So we're going to have to think about this. Am I winning? We're winning at varying speeds. We were winning fast. Now we're winning slow. I read this new book called Winning Fast and Slow. Any questions about what's going on, or are people just kind of chill? Let me heat up the water. You missed why I'm using the version on the laptop and the PC. What's the difference? The difference is, well, I mean, the version on the laptop doesn't have the new movement transaction system at all. The version on the PC does. And the version on the PC is exhibiting problems with doing relatively straightforward things. Well, they're not that straightforward, actually, but turning the right way. And so here's what I realized, though. The reason I was comparing them was to just figure out what is the frickin' difference. And the frickin' difference is that in the old system, we used to have a whole separate thing for players. I could take this out now since I know what's going on. We used to have a whole separate thing for players that that did acceleration and deceleration and stuff like that. And we got rid of that. So now when we start moving, where was my player speed? We don't need this one either. When we start moving, we don't accelerate or decelerate, right? And we move at like a 1.0 speed. See that? When we used to actually accelerate to 4.0, and what that meant was we'd be way further into the animation too, because we play the animation relative to player speed so that the feet roughly track the ground. It's a little bit goofy to do that, but that's what we do. So we're not doing that. We're playing the animation too slowly. And we don't have just the cool feeling of the player accelerating and decelerating. Because we're playing the animation too slowly, we don't turn enough because the animation controls turning. And because we haven't turned enough, we're at a totally wrong angle when we then bridge to another animation. It's interesting that we have that level of data dependency, but that's just kind of what happens. So we need to make the player move and accelerate and move fast and all that, which we always planned to do. I just forgot that we hadn't done that. And it's gonna be a little bit interesting because the way we used to preserve velocity and stuff was built into the data structures in the old system. And now I guess we want to store it on the player? Probably. Planning on buying a keyboard, do I have any recommendations? I don't. I really don't. How do we do our character animations? They're hand animated by an animator. You can't see, the thing is, I mean, you could try to motion capture stuff, but I mean, this is extra messed up because of the timing stuff we're talking about. But like, it's a non-realistically proportioned character. Like, he's more squat than a regular human being. And we have all sorts of very specific things about where the feet should be when that we're trying to control. And so motion capture is not totally viable. I mean, maybe we could have figured out a way to make it work, but so we don't use that. And there's some detriments to there. Like right now, I think when the guy moves, like his weight is unrealistically thrown forward and it looks floaty. That's actually a problem that happened recently. Well, also this totally screwed up turning is making everything messed up right now. But, you know, we'll get it there eventually. It's just not totally good. So we can do this in steps. As long as we accelerate from 0 to the target velocity, it's probably close enough, and we don't need to maintain the velocity yet from square to square. Then we'll get stuttering. But yeah. So weird, dude. I need to think about the fact that when the animation is played at the wrong speed, we just end up doing totally bad things. That doesn't seem right to me, man. I'm not I don't know. Doesn't seem right to me. Okay. Frame rate independent. Oh, the animations are frame rate independent, relatively speaking. Pretty close. That's not the problem. The problem is the acceleration, deceleration methods that control player speed are not even there. They're in the old thing. So I think, deleted everything to do with velocity. So when we're updating a linear move now, let's see. Okay, these are our linear moves. We're actually gonna do this. actually don't want a hot drink. Maybe I want a cold drink now. The tea water is just going there in the background. How can I fix the animation speed? I just said, man, we manually play it faster as you go to make like a momentum effect on the player. Okay, so do we still have the run speed function? No. What was it called? Get run speed. Yeah, I guess I didn't put that. I guess we just straight up deleted it. Stone cold deleted it. So get run speed said, well, there's a default running speed and it could be overridden. Let's see if we move these functions anywhere, if they're still here. Get run speed override. We deleted those. Stone cold deleted. We're going to have to type them in again. Okay. Let's put them here. Or get move speed override. Oh, get move speed. Oh, we did move it. Movement visuals. Here we go. Get run speed. Update guy position. No check-in because we haven't fixed this yet. All right. Great. Okay. I think that goes away. So whoops. So we have this big thing that was update guy position. And we want to think about whether we want to do it this way, because we kind of want to think about things in terms of our this. Okay. If, but we're going to do it anyway. If e.entity type is guy, we're going to update guy position edt, right? Else we do all this. And this is going to be, I don't know. I don't know if it should be here or over there. So we have this visual interpolation. That's what interp is, and that is no longer a thing. So we're going to pass that. Okay, we're going to get the run speed. Let's just see if this compiles before we even try to do anything. Declare identifier interp. Right. Right, because oh, actually this is just single. Is that right? Oh, this is not a move transaction. This is a single move. Declare identifier DT. We don't have a DT. Right. So we have to figure out how we want to do this. Let's just look at what all this code used to be. I'm going to turn off the tea water because I don't actually want it. going to want to drink something. Maybe just water, I don't know. Trying to decide whether I want to eat more chocolate cherries. Imported by Forever cheese. I don't want cheese in my chocolate cherries. You know, I might actually want to take a stream break here because this is something that I want to think about how to do separately. And we've been going 2.5 hours. It took a while to get to the bottom of this, but we have. So this is actually not bad. So there's two things to do left in, two major things to do in this movement system before I could check it in. One is to finish this. The other is to do the saving and restoring from undo of the active transactions. And I think neither of those is too terrible. This one is the more complicated one, though, because it's like, you know, we want a relatively frame independent controller on this frickin' thing. But we want it to roughly match. We want it to roughly match this. And we want to hook into all this deceleration and stuff. And so I just want to give myself a little bit of time and space to rethink about what this is. And like, how it works. The way the new transaction system works is a little bit different too. Like the transaction as a whole fires its physical movements at a specific time that is like halfway in between the expected move duration. Except this doesn't really use the expected move duration, probably. Maybe we just tune them to be similar. Maybe not. So I just want to, you know, it's like Saturday night, and I just want to kind of chill and let this go into my subconscious and do the right thing. Maybe later tonight, maybe tomorrow. Yeah, I mean, I don't really have any major issues with the basic thing that I'm doing here. It's just, you know, it's a pretty straightforward movement controller. There's some complications in the way that interacts with the rest of the game that I would like to find a way to simplify if I can, because this thing does break once in a while. This part doesn't break, but the thing that hooks it up breaks. And I'd like to avoid that. But yeah, I don't know. I think even we would ignore deceleration in the beginning. Because we only care about acceleration to get that turning correct. And then we'll see. Thank you, people, for coming by. It's been an interesting day. We've done about 5 hours and 20 minutes of programming today on stream. You took time off work to write a game from scratch. Well, good luck. It's a very difficult endeavor, but it's also very educational and very fun. So, right on, man, or woman, whoever that is. Could I take a look at the Godbolt thing? Okay, fine. Let's do that before we end the stream. So, what is this that we're asking about? Okay. If n is equal to 1, return 1. If n mod 2 is equal to 0, return collapse of n divided by 2, right? Okay. Otherwise, return of 3 times n plus 1. And it's optimized completely away so that we're basically saying return 1, right? So in this calling convention, the return value goes into EAX, right? So I mean, yeah, that's a reasonable optimization. I mean, I think this is probably something that someone hand-coded, but look, there's only 3 places to return from here. 2 of them are recursive. So the only way this can ever terminate is by returning 1, right? Or, well, here's the thing, or maybe it doesn't terminate, right? So I guess that's the thing, is I guess that would be incorrect, is like if you return a large, no, it always, okay, if you return like 11, then we'll get 34, right? And then we'll get 17, right? And then we'll get, okay, I guess this infinite loops if you pass something like 11. So this is actually incorrect, but I don't know. Like, I don't know what C++ people think these days. Do they think infinite looping is UB or something? Like, what? This doesn't seem right to me. If you pass 11, it does terminate. I don't know. I mean, so 11, right, goes here, right? So that's 34, which comes back in. Which goes n divided by 2, which is 17. So it's gone up, right? Right? Because if we get 34, we go n divided by 2, which is 17. 17 goes down here, which is 3 times 17 plus 1. So we keep going up, right? Any number with this pattern should eventually go to 1. That doesn't look obvious to me. Am I reading it wrong? Thought I might be familiar with the conjecture from before. I am not. But I don't understand why this would eventually go to 1, because the thing is, we're toggling back and forth between these. Like, it's always, okay, I guess, okay, here's the thing, is it's turning an odd number into an even number always, but it's turning an even number into an odd number sometimes. So I guess we divide by 4 or 8 or 16 enough to bring it down here. So like, I don't know, so 17 times 3 is 51, right? 52, which comes in is 26, which comes in, which goes to 13. We're still higher than our starting point at 11, but we haven't looped yet, right? As long as we don't hit 11 or 17 again, we won't ever infinite loop, right? So it's 40, 20, 10, 5. Okay, now we're down a lot lower. But wait. Okay, so 5 comes in. It goes to 16. 8, 4, 2, 1. Right, so it does hit 1. These compilers have a lot of code in them. Maybe someone just hard-coded this identity to show off. Or maybe it's a compiler bug. I don't know, dude. Numbers up to 2 to the 66. Yeah, and so if it's been demonstrated for all, so this is obviously 32-bit executable, right? So you certainly know that this is true for all 32 bits. So maybe, some college graduate student decided to frickin' put this in Clang because he had nothing better to do. I don't know. Or it could be a bug as well. The point is unterminating expressions are UB, but this isn't unterminating. Also, that's bullshit because you have to be able to infinite loop. Like, all sorts of programs infinite loop. What are you talking about? The fact that infinite loops are UB is stupid. Someone's saying infinite loop. Okay, look, if infinite loops are UB, then you just can't take the C++ committee seriously about anything ever anymore. That's insane. If that's actually true, that is insane. Infinite loops that do no I/O or UB. How do you know what's I/O? Like, I might be writing to a global that another thread reads. I might be writing to a stack variable that another thread reads. Function is either UB or 1, and it uses that to optimize it. Yeah, but that's bullcrap. If that's actually what's happening, then we have to cancel C++. I'm not a fan of cancel culture, but UB culture needs to be canceled by cancel culture. It's unacceptable. This is just bananas, dude. You left your web job a month ago to improve your C++ and think about what should you do. Well, right on. Right on. Volatiles are your friends. Maybe. Would writing something to a volatile, I guess that would prevent. So if I declare a variable volatile, then it's not UB, but if I take out the keyword volatile, then the same procedure is UB. Does that make any sense at all? Like, does anyone find that acceptable? That's crazy, dude. That's insane. What is wrong with these people? That quote is wrong. I said undefined behavior culture needs to get canceled by cancel culture. You left out an extra culture, man. In the end, it made more optimal code. No, See, that is not the right argument. Programmers need to understand what the compiler is going to do with their code. If they don't have that ability, then we're just setting up for disaster. It cannot be this complicated what the compiler does with the code. And the fact is that the optimizations that you get from this kind of UB exploitation are tiny anyway. Nobody's going to miss them if they're not there. Everybody would be a lot happier if their frickin' programming language just worked. The compiler may assume a thread either 1 exits, 2 writes to a volatile, or 3 does file I/O. In your opinion, this is disastrous, but it's a standard. I agree that's disastrous. I mean, or does file I/O? That's a very narrow definition of side effect. Writes to a volatile. Dude, nobody understands volatile or what it does. So you can't expect people to use volatile correctly when nobody understands it, in part because you kept changing the meaning of it over decades. You can't. It's so bad, dude. It's so bad. I can't wait until I never have to use C++ again. It's going to be so good. But they deprecated volatile. I don't think they did, though, because you need volatile. Or did they in like C++ 20 now or something? How do you generally detect an infinite loop? Well, you can certainly see if there's a loop with no way to branch out of it, right? With a function like the one we were looking at, it's more difficult. It becomes like a data flow analysis problem, because whether you recurse infinitely or not depends on, you know, what the value of the parameter is. And so probably the way that was optimized, it probably wasn't someone programming that conjecture in. They probably said, look, infinite recursion is illegal. So the only way this returns is returning 1, right? Now, here's the thing, though, guys. I think infinite loops being illegal would be BS, or being UB is total BS. Like UB, the whole concept of UB is BS, all right? They picked the wrong acronym. It shouldn't be UB, it should be BS. Behavior subspecified, right? Instead of undefined behavior, it's behavior subspecified. There's good things that should be UB. No, there's nothing that should be UB. 0. The concept of UB should simply not exist. All right. That said, there are different levels of how heinous and egregious this violation is. And saying that infinite recursion is UB is a little bit better, because an infinite loop actually can physically run on a computer. Whereas infinite recursion, if you don't have like tail recursion optimization or something, according to the machine model, will run out of stack space, right? So I actually am I'd need to think about it more, but I'm kind of okay with that being a recursive function where that gets optimized out, because you would crash otherwise. I mean, maybe that's legal behavior to write a crashing program. I don't know, but it's better than if it was an iterative loop. My question is, if you rewrite that to be iterative instead of recursive, then what happens? And the answer is, it is probably even more obvious that it only returns 1. So it probably especially gets optimized. I don't know. Maybe that's actually what they do, is they convert it to iterative and then they're like, well, the end. Okay, please stop saying these false things about UB. You're saying what saves us from UB is that there's only one implementation. Once there are two or more, you'll have to come up with a pretty spec specification. That has nothing to do with it. I've said this many times on stream. That has nothing at all to do with it, okay? The problem is not that every single detail is specified in advance. The problem is what it means to not be specified, right? And the C++ people chose the most bullshit definition ever. They said it's not a valid program unless it conforms to behaviors that are completely specified, right? That's what UB means. And that is disastrous. You cannot do that, okay? The right thing to say is that things outside what the spec says are implementation specified. They're not undefined. They're implementation specified. And they're specified to the degree that you can. So for example, I don't think we're going to have this problem in this language, but if you had like the C++ shift problem where you say like, well, what happens if we shift something by 64? Different CPUs do different things by default, right? Is that UB? Say no. Just say in the register or in the value that was shifted by 64, an implementation defined value results, right? So that restricts the scope of what is unknown to simply say, well, maybe the value is going to be the original value. Maybe it's going to be 0, whatever, depending on whether it's a, whatever. People know what I'm talking about if they're familiar with the problem. That is what you do. You don't say, we don't know, it's not a valid program, we're allowed to launch the nukes when you do that. That's crap, dude. That is super crappy, and it's basically unethical. But they do it. How is it different? It's just the naming thing. No, it is not just the naming thing. The reason is your CPU defines that behavior. Okay, here's the point. When C was made, when the C programming language was made, in the spec, it left this open because they know that different CPUs do different things, right? And the de facto situation was that the language is one part of the spec, but the machine you're running on is the other part of the spec, all right? So language plus system completely specifies everything that happens, all right? As things evolved, greedy, unethical compiler people decided that the machine is not part of the specification, or the system is not part of the specification, and the language only is the specification, right? And that if you write anything that is outside what is specified in the language, then your program is invalid and we can do whatever we want, including launch the nukes. And by the way, the language definition is so Swiss cheese that it's very hard to write something that doesn't step outside the spec. So we're going to be launching nukes all the time, right? That's crap. It's terrible. It is obviously awful. And I don't understand why there are so many apologists for this. It's ridiculously absurd. All right? The right way to do it is you just say there's no such thing as UB. There is such a thing as a system-defined behavior. So the compiler, if the compiler doesn't know exactly where this thing is going to deploy, it's not allowed to assume what the system-defined behavior is going to be. What does that mean in a case like this? You don't optimize that procedure. Isn't that bad because you won't optimize as much? Well, not really, because you at least won't make the program incorrect. And you at least won't surprise the programmer. And to the surprise of compiler people, when programmers understand what the hell their program is going to compile into, they're much more able to write code that turns into something efficient in the first place. Nobody tries right now because they have no idea in C++ what their code turns into. The reason I get mildly emotional about this is, one, I don't understand why it's so hard for people to understand this, because it's actually pretty simple. Maybe you just had to be there in the C days to know this stuff, but it's pretty simple. It's like people have this weird Stockholm syndrome, and like, there's like a lot of gaslighting that goes on about this stuff, pretending these things are complicated. They're not complicated. It's pretty simple what the right answer is. Okay. And secondly, in this way that I've given speeches lately about how we're building up this very large mountain of complicated things that nobody understands and that are too complicated to maintain and way more complicated than they deserve to be, this is a key piece of that, right? The compiler is the thing that determines what all your programs mean. And if you have no way of understanding as a day-to-day programmer what the compiler is going to do, give up. You can't program. What are you going to do, right? It's absurd. It is critically important that programmers be able to look at a piece of code and predict what the steps are that the compiler will do to that code. Certainly at a semantic level, if not at a speed optimization kind of level, right? And the problem with all this UB stuff is, in the name of optimization, they change the semantics of your program. Not cool, because you remove the entire ability of the programmer to understand. All these programs would be solved if we just launched the nukes. That is true. Maybe if I just recompile my game enough, or my compiler enough, because the compiler is in C++, or we'll go back and compile the witness a few more times. Dude, I'm sure the witness has lots of UB in it, honestly. Maybe one of those times we compile it, we'll launch the nukes. Why not? It's allowed to. Compiler's allowed to. Make sure you write a lot of UB to make your code faster. We're running low on developers, according to Microsoft. Yeah, the reason we're running low on developers is we've made everything many times harder to do than it should be. So everybody is fired. The witness took so long to make because nukes were launched mid-development. Yeah. All right, well, I ranted again. Great. I also called compiler developers unethical for the first time. I don't think they're trying to be unethical. I don't think they think they're unethical, but the behavior is de facto unethical. Like, that behavior, if we had an actual software engineering code of ethics, if it were a reasonable code of ethics, I think that exploiting UB to the degree that like Clang and GCC now do, I think Clang is probably way worse about it. That would have to fall afoul of any reasonable code of ethics. I don't see how it wouldn't. It's just that nobody cares because it's a total clown show. Does UB affect this compiler? Well, I don't know, because the compiler is written in C++, and we've established that if you accidentally do UB, which is almost impossible not to, that the compiler can do whatever it wants there. So whatever, man. Maybe UB means the compiler can eat all my choco cherries And then I can't have any. How about when you use LLVM as a backend? Well, LLVM is a backend for a lot of languages. The question to me is, how liberal are they with applying these kind of optimizations generally, unless you explicitly tell them not to? We are not very careful about telling LLVM what not to do yet, but we're going to be. I don't think we tell it that it's compiling C++ though, so I'm hoping it's not applying any of those things, but I'm not sure. And for all I know, LLVM has lots of UB baked into the IR. Like, we're probably doing IR UB all over the place, dude. Because again, that's just what happens. Will we make it self-hosting? We will eventually. Because again, that's the way to guarantee that none of this stuff is a problem, but we can't do it yet. An empty infinite loop will be UB for LLVM. Dude, that's when you start hitting the computer with a baseball bat. Can I compile collats and see if it optimizes away? I mean, I guess that's an interesting experiment to do. Somebody link me that again. We'll do this just to find out. It might actually. Wait, it was x mod 2 is equal to 0. That's the same thing, right? But what was it? X. No, if x mod 2 is not equal to 0. No, it's if it's equal to 0, return x divided by 2, right? Otherwise, return x times 3 plus 1. That was it, right? I mean, it wasn't structured quite like this, but I think that's the right function. I don't remember if we build debug or release by default. Let's just compile this first. Oops. Oh, test. So I'll reopen this just to make sure that we got it. N divided by 2. You know what? I might as well just put it the same way. It was just an else here. I used x instead of n. Okay, so I don't remember if we even... So we're using LLVM. I don't remember what our optimization level is by default. Optimization level is 0. See, the thing is, okay. I think I could do this. This is a messed up level function because it just takes integers. And it doesn't even, ugh. Dude, we got to fix this. All right, so we do release if opt level is not 0. And does that get used? 3. So that's like the -o parameter. All right, something like that. So hopefully we could do this. I'm actually not sure. Oh, we got to import compiler. Okay. Who frickin' knows? Like, usually when I build an optimized build, I do it with a separate meta program. Anyway, this should be okay, I hope. Now, let's debug it. Test. Debug. How do we step into F11? All right, system entry point. Program main. All right. We just went straight there, apparently. How do we do view disassembly? There is no X. Ugh, come on. We built this 4 times, apparently. That must be LLVM having built it 4 times? Okay, this one, I mean, I don't know why it built 4 versions of it, but, or maybe they're all the same. So this one definitely is not optimized out. It's definitely calling functions. It's not inlined. Okay. So that's good, actually. Let's see though. Let's go to all of them. So go to disassembly. So that was the first one. B8, BE. These are like the same, I guess. These might be different ones, but this is just a few bytes apart. Let's go back there. B8, BE. So for some reason it thinks these are both entry points. This instruction and this instruction, right? All right. I don't know why the back button doesn't take me to the right place, but whatever. Go to disassembly. So 5F3. It just jumped me to the same place, even though I said oh no, okay. Right, it put the arrow down here, but it jumped me here. Okay, never mind. So these are just different clauses inside the same function. So it did only generate 1. I don't know why it's asking for different basic blocks, but it is not optimized out, which I am happy about. Oh, right. Okay. actually, it's supposed to be unsigned, right? Which we didn't. I made it a different type. So int is signed 64, so let's make this U32. I hope it's still okay, but let's see. Let's run it. Okay. Debug step into. Okay. Go to disassembly. Oh, wait, there's fewer of them. But it is also not optimized out. Thank the Lord. So yeah, so whatever you need to tell LLVM, we are not telling it. That said, I mean, did I correctly set the optimization level? Maybe. How would we, what's a good test to make sure we're on -03? Like, can I put something into main? How would we know? It does optimize out in Rust. Well, have fun. Please enjoy this version. Okay, great. That's, yeah. You know, like I said, calling infinite recursion illegal is a little bit better, but I don't like it. I really don't like it. I don't think it's good. Collatz 27 is the first long sequence. Long how? Like how long? Like how do I know? Well, whatever. So the question I have is, what is some simple program I can just put in, or some simple code that I can put in main to test that O3 is really optimizing? Like maybe some loop lifting thing. All right, so 27, whoops, basic, not print. Okay, what if I just do this? X is 0 while X is less than 100, Y is 7, Z is Y plus X. Print hello whatever. I don't know, like I just want to see if like some code motion is happening, right? All right, well, we just jumped straight here. Okay. What is all this? It's like restoring a bunch of registers that it saved. Yeah. See, because this isn't inline, there's all these like callee save registers and crap that it needs to do. All right. So we're putting something in 7, but the jump is to 2850. This is not optimized, guys. This is terrible. So we actually can't come to any conclusion because it's like literally not optimizing right now. I'm not sure why. No, I never increment X. Oh yeah. Good point. But it still should have done some code motion there. So we're whoops. Wait, what? Debug step into going here, going. Why is it going to collapse now? I didn't want. What? Did it like get rid of the whole? What is going on here? No executable code is associated with this line? Bro, sure it is. It's running. Maybe we're not outputting good debug info. Well, should be set. All right, these are the options that we set. Optimization level, release, executable. Oh, we do have bound checks on? What? Bro. That's not. I guess our utility function here doesn't set that. See, we don't usually use this function. For Sokoban, we use a different function. So we're just going to turn those checks off. Whoops, I'm compiling the wrong program. There we go. Okay, so array bounds check off, cast bounds check off. Good, good, good. Emit debug info. It should be emitting debug info. Oh, why are we? What is this off for? Do we need to turn these on specifically? What is re-roll loops? Is that the code motion that I'm talking about? I don't know, dude. We basically at some point just need to do a lot of thinking about what these settings really should be. So we have tail calls. Oh, re-roll means if something's unrolled. We don't want that, actually. It's like the reverse of unrolling, right? Okay, whatever. Whatever, man. So we claim that this is what we're doing, but I'm not really... We didn't really get the right debug info. Like, we're just not hitting this breakpoint. Just not hitting that. It's like, come on, bro. What? We're hitting that. So why can't we go to main? There's collats. Why do we have no main? We had a main a minute ago. This is all runtime support stuff. I don't know, people. Main gets inlined into system entry point. Quite possibly. Right, because the compiler doesn't know. Well, no, okay. So system entry point. Yeah. Let's see. Yeah. Wait. I mean, I don't see any. Oh, yeah, it's calling print down here and stuff. So, yes, LLVM inlined our main into system entry point. Okay, well. It didn't really do... Oh, okay, so here, okay, it did constant folding of the 7. See this? All right. So now this makes sense. So here we said, hey, y is a variable that's 7, and z is y plus x, and x plus equals 1. It didn't even bother lifting this out of the loop, because it was just like, look, let's just do x plus 7 every time. Right? And that's what it's doing there. So it is optimizing. Right? I don't know why people use load effective address for ads. Oh, I guess because if it's 7, right, if it's a small number, you don't have to load the constant. Like if you use an add, you have to load the constant into a register. That's something we should do at some point. So basically x86 assembly has this kind of adding of a small constant like in there built into the instruction set. And a lot of instructions can do this. It's like a basic feature of it, right? And so this is a little bit abusing that, but it's not really abusing it because this is what machine language is about. Yeah. Okay, so, you know, all I wanted to do was verify that it was optimizing, which it is. So now, though, let's go verify that it didn't. Okay, so here, it didn't inline this one because it's recursive, right? So, yeah, okay, it's not optimized out. It is optimizing. It did not optimize this. So that is good. That is good. LLVM is not being too presumptuous about spreading its UB disease to all programming languages, which is good. I'm very happy about that. Hardware devs are familiar with LEA abuse and it's become part of the standard toolbox of instructions. Yeah, totally. Totally. No, I mean, I'm sure, yeah. Yeah. So for people not following along, load effective address is supposed to be more like this thing is a pointer, right? And we're doing some math to like array index or something, you know? And then eventually we're going to dereference that final thing. But it's like, look, a pointer, they try to avoid teaching you this in school, but look, a pointer is just an integer. Pointers and integers are the same thing on a computer, okay? On any modern computer. Well, unless it's got like heavily segmented memory and then, but I don't think there's any practical system like that today. So certainly on a PC, pointers and integers are just the same thing. And so anything that you could use to compute a pointer, it's like, well, if we just want an integer, we can use the same instructions if they're faster. And so that's what's happening there. Just heard an interesting talk by Tom Forsyth today on it. Was that at Handmade Seattle or what was that? I was going to go and then I had too many things happening here, so I didn't go. Hopefully I can watch the streams later. He worked on Larrabee, so he probably has some interesting comments in that area. Okay, anyway, this has been fun. So my goal is I want to figure out what's the best way to do that player acceleration and deceleration, and maybe we'll program that tomorrow. We want to do it soon because the thing is, like I said, so first of all, I haven't checked this change in from this machine. And like I said, I don't want to destabilize the compiler and the game. But also, the longer that I keep this movement thing checked out, it's been like a month already or something. The longer I keep it checked out, the more the rest of the game is diverging. And the more likely it is that we'll have some incompatibility with what I've done with what's been going on, and then that's more work for me. So it's really in my best interest to like get this done and get this checked in. I think we're a lot of the way there. We've got a couple major things to do, but this is good though because it's basically working, and that makes us happy. So see you all next time. Thank you for coming by.